We're now going to do part 2 of exercise 9.14, and here they want us to give an argument or some kind of an interpretation falsifying the opposite implication. So we want to show that this here is not valid. So remember the previous implication was that this last part here implied this, and we're going to show that the opposite implication, so that this implying this is not valid. So it's not satisfied under every single structure M. There is some structure M in which it's not satisfied, and we're just going to come with that structure M. We're going to come with an example. And then after that, we're going to use this to show that B being satisfied under A does not imply that B is a logical consequence of A. Okay, so what kind of structure could we create to falsify this this formula here? You can think about that for a second, and then I'm going to go on to the solution, or the interpretation that we're using in the solution. So in the solution that you're going to get, our structure M is just going to have the elements 5 and 6, and we're going to let A be a unary predicate P, and we're going to let B be the unary predicate P also, but with the for all quantifier, which binds the X. And then we're going to let P under M to just be the set with the number 5. So now let's look at what this interpretation here has to say for our formula. So our first part here, clearly for any assignment V, this is true. So this holds if either P of X is 0, so either this first part here is false, or the second part has to be false. But the first part and the second part are really just the same thing, because here this for all quantifier gets put in here, and here we have this for all x px here. So if this is true, then they're both true, and then it's true, or they're both false, in which case it's also true. So this here will always be 1 under every under this structure M. On the other hand, we have that for all if the consequent is supposed to be true too, this means that for all A implies B under M and V, which if we put in the definitions of A and B becomes for all x, for all x, and then brackets px for all x px. So this quantifier covers all of this, but this quantifier covers just this px here. And remember that this quantifier, like this one, doesn't touch the one inside here. Yeah. So this is true if. So we either need this part to be false, or we need this part to be true. So for this first part to be false, it means that either for all x is such that there is no x. For all A in M is such that there's no A in P, or for all B in M, all. Okay, I think this one is a bit wrong. So what they're saying here is that either this has to be false, so there has to be some kind of an A in M such that A is not in P for this to be false. And then for the second part, for this to be true, it has to be such that there doesn't exist. So there doesn't exist some A such that A is not in P. But here we reach a contradiction, because in the first part, for this to be false, there has to be some A which is not in P. But for the second part to be true, there has to not be the case that there is some A that is not in P. So this can never be the case. Hence, this here can never be 1. It will always be 0 under this structure M. So this means that M does not satisfy for all A implies B, and hence, if M doesn't satisfy this, it means that M does not satisfy this here. If we go back to here we are, definition 9.23, B is satisfied under here. A implies B is only true if it's satisfied. So we're showing that we're essentially showing that it's not satisfied, and therefore the implication of this implying this is not true. So we've concluded that because we have come with this interpretation, this M, and shown that there is an M under which this valuation is not satisfied, it is not the case that it is always true. So it's not a tautology, it's not valid, and therefore we cannot have that this here implies this here. So for all A implies B is not a logical consequence of for all A implies for all B. Okay, so that was the first part. Now the second part here. We were asked to show that we're going to use this new information to show that B being satisfied by A does not imply that B is a logical consequence of A. Again, we're going to do this by contradiction. So we're going to assume that it does. We're going to assume that this implies that B is a logical consequence of A. And if B is a logical consequence of A, then if you look at definition 9.23, this means that A implies B is valid. And by fact 927 here, we have that if A implies B is valid, then we have that for all A implies B is valid. Which means that we can also have that C implying this, for some random C, we have that C implying this is also valid, because for any, being valid means that for any M and V, this holds. So if this holds, and by letting C equal this for all A implies for all B, we get this line here, and we're saying that for all A implies for all B implies for all A implies B, that this is valid. But now we've reached a contradiction, and you can think about why we've reached a contradiction for a second. We reached a contradiction because we just showed that it is not valid. There is some kind of an interpretation which we just made, under which it is not satisfied. So we're then shown by contradiction that B being satisfied by A does not imply that B is a logical consequence of A.